All right, goal A3. This will be or is our third method of solving a system of equations. So you will have to know all three methods. You have the graphing method and the substitution method that assessment that you got back today. And then this is the third method. I personally think this is the simplest one. This is probably the one, if given a choice, that I would choose. And when we get to the word problems, you'll get to choose which method you want to do, but otherwise it'll be specified which method I want you to do, okay? So sometimes you're probably going to hear me say linear combination because that's what they used to call it more commonly years ago. Now they call it more so elimination method, but both descriptions kind of describe what you're doing. Linear combination, you're combining the two lines together. These are linear equations. And your goal ultimately is to eliminate a variable. So both things that they call it make sense. Okay? It is really, 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 really important that your x, y's, equals, and constant are lined up. If they are not lined up, that needs to be your first step. I'd like to have my variables on one side and my constants on the other side, although it doesn't really matter, just so x's are on the same side, y's are on the same side, constants on the same side. The ones that you're going to see me do, and for the most part, they're going to be set up with x's and y's on the left, constants on the right. Okay, so that's the way you're going to see me approach them. And you'll see me do one or two, I can't remember, where that's not lined up, and we'll get it that way. Okay. Basically, there are 4 scenarios, okay? So I'll start with the easiest and we'll build from there. Remembering that your goal is to be able to add down, just add the equations together. When they're lined up, add down, and a variable gets eliminated. Okay, that's the goal all of the time for the elimination method. So the first one that we're going to do, the simplest one, that's going to happen immediately. I don't have to do any work to make that happen because positive and negative 3x are going to be canceling out when I add these together. Okay, that's what you want to happen. Okay, so the first example, I'm going to add positive and negative 3x cancel. Positive 3 gives me positive 6y, equals comes down, negative 6 and 0 is negative 6. And I solve that. It should just always be a division. One step there. And y is negative 1. Now, unlike the substitution equations, there's not an equation that's better than another to substitute this or plug this into, I should say. Okay? In substitution, there was always a good one, okay, to find the other value. But here, it really doesn't matter. So you take negative 1, and you either take it to the bottom equation or to the top equation. I'll go to the bottom. And then we're going to plug that in for the y. Okay, so we're going to plug that in for the y value there. Okay? So I'm going to have 3x plus 3. We just found y, negative 1 equals 0. And I solve that now for x. So 3 times negative 1 is negative 3 equals 0. Add 3 to both sides. And 3x equals positive 3. And then divide by 3. And x is 1. So 1, negative 1 for my final answer. Questions so far? Yes?
Why wouldn't we use the y on the top?
You can put either one.
Oh,
It doesn't matter.
Okay.
Jordan?
So we could also do negative 3x plus 3y equals negative 1, and we get the same answer.
Yep. No. Say that again?
So like if we use the top,
We have Negative 3x minus
Or-
3 equals negative 6.
Oh, wait, no, my bad. I forgot where we started.
Yeah.
We were using y.
Okay, second example, I'm building. Remember, there's 4 things. Your goal is the same every time. You want to add down, and a variable cancels out, eliminates. If I add down here, that's going to give me 6. And I add down here, that's 22. So a variable is not canceling. However, my coefficients on the y's are the same. So if one of them were negative, it would work. So you make it negative. Okay? But you can't just make that one thing negative. You have to do a transformation to an entire equation. You can't just change one little thing. So you pick one, and it doesn't matter which one. I'm going to go with the bottom. And I'm going to multiply it through with a negative. So my top equation, I am a rewriter. You're going to see me rewrite. Anytime I have to make a change, even if it's one change, I'm going to rewrite this so I don't lose track of where I'm going. I didn't change the top equation at all. The bottom equation becomes 2x minus 11y equals negative 7. So all of my signs change to the opposite when I multiply it through by a negative. This becomes positive, this becomes negative, this becomes negative. And now I add my 2 equations together, combine them. 8x plus 2x is 10x. Positive and negative 11y cancel, that's what we want to happen. 37 and negative 7 give me 30. And then divide, and x is 3. I have, yes sir,
So, why did you change it to negative 4? So
because you have to have something cancel. Something has to drop out, be eliminated. Either x or y has to eliminate when you add them together. I have really 3 places I could go. I can go back to the original 2, or I could even go to the one I multiplied through by a negative. I always go back to one of the original questions, but it really doesn't matter, okay? I'm going to go right to the bottom equation there. You found x, so I'm going to plug 3 right there. So negative 2 times 3 plus 11y equals 7. And I solved that. Negative 6 plus 11y equals 7. Solving for y, so I'm going to add 6 to both sides. 11y equals 13. And then divide by 11. And y is 13/11. Leave it as a fraction. So I have the order paired 3 13/11. Just like graphing and substitution, all of these answers are checkable. If I go to my calculator and do 8 times 3 plus 11 times 13/11 equals, or enter, I should get 37. And then negative 2 times 3 plus 11 times 13/11, enter, and I get 7, then I know I'm right. Every single answer is checkable before you turn something in. Every one of them. Okay, question on that one. Your goal is the same. You want to eliminate a variable. If I add this down, 8x, 4y, nothing drops out. The coefficients are different. 3 and 5. I can't just change one of the signs and make it work. 6 and 2. I can't just change one of the signs and make it work. But your goal is still the same. You want something to drop. So let's look at those y's. And I'm looking at the y's because my signs are opposite, okay? what could I do to the bottom equation to make my y's drop out? Yes. Multiply it by 3. Because if I take this times 3, that'll make it a 6, and then they would cancel. So that's what I'm going to do. I'm going to take the bottom equation times 3. So again, your goal is to make it happen. It's figuring out how to make it happen. I'm not changing the top equation. The bottom equation becomes 3 times 5, 15x, 3 times negative 2 minus 6y, 3 times 14, 42. And then I add down. 3 and 15 is 18x. My y's are eliminated. Negative 6 plus 42 is 36. And then divide by 18, and x is 2. And then I gotta find y. So I'm gonna plug in. And it doesn't matter if I go to the original, top or bottom one, or even to the one I multiplied by 3. But I always go back to one of the original questions. So x is 2, so I'm plugging 2 in. So I have 10 minus 2y equals 14. Subtract 10. Negative 2y equals 4. And divide by negative 2. And y equals negative 2. Okay, question on that one. Yes, sir.
The 3 that you used to multiply, did that come from 3 up top?
Nope. I figured out, well actually Drew told me, but I wanted to make this a 6. Because that one is a 6. So I wanted to make it a 6 so that positive and negative 6 would cancel. So what would you multiply 2 by to make it 6?
Okay.
That's where that comes from.
Can you